Recording in progress. All right, so let's do a script. This is going to be this is still part one that we're going to look at next. So I think we started this script in class the other day. What did we call it? Uh, did we call it Chapter 7, Part 1 in class? Anybody remember? Or did I do that later? We get a Chapter 7 for script? Victor, what do you got? You have a script file from Chapter 7, Victor, that we started last time? Lily?
I think it was TS because I remember I asked you about it doesn't matter if it was TXT or TS script.
Yeah, and we can use either TS or TXT. The extension is just there really for us. And I was using TXT before because it is a text file technically, but it's a TypeScript text file. So I decided TS was a better extension, just to remind me what I'm looking at there. Yeah, so if you can find the file that we worked on last class. So for example, if you haven't played with it since last class, if you do an LL on wherever you have stuff, and I think last time I had put it in my root directory, but I moved it after.
Chapter 7 TS.
Just Chapter 7 TS? Okay, yeah, so append to whatever we did last time, and we can change the file name later. So I'm going to do a script. And I don't, just double checking, I don't see anything else there. I'm just going to pick up there. Oh, this is in the way. -A. And I had moved mine to Chapter 7. And this is going to be in the way no matter what, isn't it?
You're recording for everybody online.
I am. Okay, so that should work. All right, script recorded. I'm going to clear my screen, get that at the top, move this to the bottom. All right, so let us take a look. Remember that password file that we looked at before? So let's do a tail on that. So tail / etc pass tab should bring up passwd, and tail will show us the last, I think, 10 lines of that. And you're probably going to see your user in there when you do that. You should be user 1000. Okay. And can you see there's a whole bunch of colons in here? Yeah, so you may have heard of a CSV file before, comma separated values. That sound familiar? Nope. Okay, so there's all kinds of file extensions out there. When I'm doing a simple spreadsheet, I might save it as a CSV file, comma separated values, which just has a list of values for every row in the spreadsheet, all separated by commas. The password file is a colon separated file. So the colon separates the different parts of what password has. And if you do a man on PASSWD, you can then look up what each of those columns stands for. Okay. We are going to take a look at parsing this with, let's try awk first. So we're going to bring up that command again, and we're going to use pipe to send it to another program. The program I want to send it to is the program called awk. And awk is a command line program that allows you to explore, search files in a slightly different way than grep. Sed is another program we'll take a look at today. And what we want to do with awk today is tell awk to look for lines that have bash in them. So we'll do a /bash/. And then after we find those lines, then use a curly bracket to then print. We want to see the first element in there. So a 1. And then we want to see, let's go 1, 2, 3, 5. So let's go $5 and then close your curly bracket and then close the quote.
So you need a hyphen to search from 1 to 5?
I want to see 1 and 5.
This is the
Oh, good question. What distribution are you running? Ubuntu? So awk didn't come up. Oh, that's so little up there. sudo app. So do an apt search for awk. Let's see. We're probably going to get a lot of stuff. Gawk would probably work in place of awk. Yeah, I would install Gawk, Gawk. That should do it.
That's weird, because like, Ubuntu,
You probably installed through browsers.
And then just for future reference, when I would recommend jumping to another shell that script isn't in when you do an install, so all that stuff doesn't get dumped into the script file. So let's see, what do I have installed? If I do a dpackage -L, we'll list files if I have it. Do I have Gawk? I do not have Gawk installed, but Gawk is a upgrade of awk, and it should also use awk. That's my recollection. All right, let me know if that doesn't work. All right, let's see if this actually runs. Did I type it right? I did not type something right. What did I get wrong in that command?
Man, you got your phone number now.
Oh, awk is thinking that my thing is space separated. So let's fix that. So back here in front of awk, so if I were to bring it back, do a -F, and then after the F, put a colon, because we're going to change the way it's looking for the separator there, the delimiter. And it almost worked. Let's see, I got the username. I want that. Good. And then let's see.
you have a phone number as a username?
You remember when we made the users on the server using the add user commit utility, which is a Debian utility? It asks for things like what's your real name, what's your phone number, what's your office. So when I made the user for my cat Morwenna, I actually typed some things in for her user, as opposed to when I initially installed the system, the Debian installer asks, do you want a normal user? You really should have one. And then it only asks for a username and a phone number. I'm sorry, a username and a password, excuse me. But if you add users later, then you can add more details about that user, and that information gets stored in the PASSWD file. So the password file, by the way, does not have passwords. Has everyone noticed that? Okay. Anybody know where passwords are stored? Nope, they are still in the etc directory. I think they're in a file called shadow. Let's see. So if we do an ls/etc, yeah, just for fun. Yeah, I think shadow. Oh, I meant less. I want to look in it. Permission denied. I'm not root. Confirm. So if I come down in here, so you should see that for my user Gary Morwenna, there's this crazy string there. So that's the password I've memorized to get into my system. I just type that every time I want to log in.
Ever take a picture of it?
Take a picture of it quick. Yeah, so that's that's what an encrypted password looks like. And it's encrypted with what's called a one-way hash algorithm. So what that means is I could give this out on the internet and nobody could reverse engineer it to show my actual password. What they could do instead is if they knew what hash algorithm was used to make this, they could go through a string, a list of possible passwords and compare those hash outputs to this to see if they found one that matched, right? Which is a tough thing to do if it's a good password, right? So I usually use passphrases, so multiple words together that I can remember. And that's harder to break than, say, a 10-digit password using things you can type on a keyboard. Okay. So I recommend, not using like a 10 or 12 random string for a password. Passphrases of 3 or 4 words are better in general.
You have a bunch of random numbers and letters and stuff, is like my actual, I maybe know. After like work on it.
Yeah. And I mean, there's nothing wrong with using all the characters you can get off the keyboard in 12 digits or so. But passphrases are easier to work with and just as secure if they're reasonably long. 3 or 4 words is long enough. All right. Okay, so those are passwords. Let's get out of there. Q to quit. So let's see what else I want to do there with that. Let's compare that to using cut. So we can do the same thing with an app called cut. So bring up that command that we had typed before with tail. And actually, let me get that to the top of the screen so it's easier to see because my zoom is in the way. So I'm going to tail /etc passwd. And again, keep practice using tab, type as little as possible whenever you can. We're going to pipe that over to a command called cut. And we're going to tell cut that the delimiter is the colon. So that's how things are separated in here. And then we're going to get, cut. Remember I mentioned the idea of a spreadsheet earlier and the idea of comma separated files for a spreadsheet. So each row in a comma separated file is a row in a spreadsheet, and the comma separates the values for the columns in the spreadsheet. The cut command treats the file you give it like basically a spreadsheet that's made up of rows and columns. The default delimiter that it expects is a space. So for example, remember that prologue from Shakespeare we grabbed from the book last class that's listed in this chapter? If we had cut look at that file right there, it would see each row as like a row in a spreadsheet and each word as a value for each column in the spreadsheet, unless you tell it we're separating with something else. So here we're saying we're separating things with a colon. So here we're going to grab fields 1 and 5. And the only thing I forgot is, does cut start counting with 0 or 1? Because some programs you'll find start counting at 0, 1, 2, 3. Others start counting at 1, 2, 3. We'll find out. I think that looks right. Enter. And let's see, where's the Gary line? It grabbed 1 through 5. No, it grabbed 1 and 5. Yeah. Yeah, so that's similar to the output we saw before, except we didn't get to filter. So awk can filter and then discriminate on what you load. Cut can't. What could I use to only grab certain lines here in between if I wanted to use cut instead of awk? Like Nathan said he didn't have awk. What if he was on a server he couldn't load awk? What command do we know that searches for things in lines of a file? grep. Yeah. So let's up arrow and we're going to amend this. So before we get to cut, what we're going to do is we're going to insert a pipe in between. And then in between there, we're going to do a grep. And we're going to have grep look for bash. So what this should do is only grab lines that have bash in them, then send it to cut, and then cut will separate things based on the colon and give us the first thing it sees and the fifth thing it sees for each of those lines. So hit enter. So that looks more like what awk gave us before. Okay, so one thing you'll find out in Linux is it's developed so much over time. There's lots of different utilities that they do similar things in slightly different ways. So there's all kinds of ways to get the same output with different commands. So here we used grep and cut to get what awk did in one shot. I think cut's easier to use than awk. Awk is harder to use, but it does more stuff. There's another program the book goes over called sed. Sed is kind of like grep in that it can search for things, but sed can also replace stuff. So not only can you search for something, you can also do a find and replace with sed, which is kind of cool. All right.
Top nine have three columns.
The Gary.
After Gary Parker.
Yeah, so that is in so if we look at the original, so let's do to double check. So and we can check on yours too. So I'm gonna do a tail. Actually, I'm just gonna do a cat on no, I take that back. I'm just gonna go straight to grep. And in grep, I want to search for Gary, and I want to do so in the file etc, etc PASSWD. And then what grep will do is it'll find any line with Gary in it and spit it out. So notice that there's Gary colon X colon 1000 colon 1000 colon, and then it's Gary Parker comma, 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 right? So if I compare that to Morwena's line, so let's do, instead of doing a grep for Gary, I'm going to do a grep for bash. That should bring up Gary root in Morwena. So what's the difference between the Gary line and the Morwena line? We've got the username. Forget what the X is for. The next thing is the user's identification number, then the group's identification number, and then the next field is information about that user. So I mentioned the Gary Parker account came when I was doing my installation, and the installation program asked for what do you want your user to be? What's your real name? What's your password? That's all it asked me. When we did the add user command in class the other day for the server asked us other questions like what's your phone number? What's your work number? What's your office number? And it asked for other information. So those commas are those possible other fields that the installer skipped, but I did with add user. So that's why this looks like
Is that why the name is Morwena being dead Rocket Kids and Parker?
Yes, so she's had many, I think I missed a couple of names in there, but I don't know if you have pets, but you know, like humans, we get nicknames and my cat has a lot of nicknames.
You named your cat Bean Dip?
So.
Yeah, but my older daughter had her, when she just went to college, had her friends over for Roundup because they'd never been to Pendleton Roundup, and one of her intoxics with her friends thought the cat would be called Bean Dip. And it stuck for a few months.
Let's just say that's the full name.
Yeah, that's the full name there. All right. So, okay, let's do a couple of other things with this, and then I want to move on to variables. Let's combine this with file redirection. So suppose I want to save some of this information and not just display it. So I want to go back to the line about cut. So let me get that up at the top. So up arrow till you get the tail command with the cut. I want to save this information. So one way to save it is to use the redirection operator, which is the greater than, which points to the right, which means take this information and stash it somewhere. And I want to put it in a file called users.txt. What's the difference between using the single arrow and the double arrow on the redirecting standard output? Anybody remember?
Does the double arrow like cut and paste it?
Almost. Think about how we use the script file, the -a or no -a. What does the dash A do as script? Yeah, it adds to the end of it, appends, yeah. So the double arrow will append to whatever's there. If nothing's there, it just makes a new file and puts it in there. The single arrow will overwrite if there was already a file called user.txt, kind of like the dash A when we use script. Okay, so that's something to pay attention to. I know I don't have a users.txt, so that should be okay. So if I hit enter, okay, now problem with this is I don't see what happened. Okay, so one thing I can do to see what happened, so after I'd have to go do something like cat users, and then I can say, oh, it recorded all that, which looks different than what I got before. Oh, no, that's what I got before. Oh, because I didn't do the grep filter. Ah, okay, I got to fix this. So we're going to do it again. I want the one that wasn't just the cut. I wanted the one with the grep and cut. This one here. All right, so I'm going to redirect that to users. Now, again, if I do that straight redirect to users.txt, I'm not going to see what happened until I cat it later. So there's another program you can use called T. So instead of redirect, I'm going to pipe it to the, yeah, so I want to pipe it to the program called T, and I want to tell T to store the output in users.txt. Oops, txt. So I'm not using the file redirection this time. I'm using a pipe to send it to T. Think about the letter T, right? It branches out. So what T does is it branches the output to standard out and to a file. So then I can see what's happening and store it at the same time. So run that.
So why wouldn't you just like default out?
Because sometimes I don't care to see the output. I pretty much know what's going to happen. I just want to store it. But if you want to see it, like suppose I was running this in a shell script, the shell script or the user doesn't necessarily need to see the output. They just need to store the output. And I'll show an example of that in a minute where I don't really care about the output at first. I don't want to see it. So I wouldn't use T. So if I hit enter here, it'll show me the output. Now, formerly in users was all that stuff there. So now if I cat users.txt, I should see it got overwritten and has only those lines in it. Yeah.
So even before we got to this point, when we were first trying to see all the users.
Yeah.
My main user, the iTrilly, etc.
Yeah.
Never showed up, but it kept showing my secondary user I had set up a while back.
Okay. So did you view the full file?
Yeah, so we did everything initially. That first one, it showed my private, but everything up till then, it just kept showing my secondary.
Yeah, so depending on your system, there could be a lot of users in the system. So a user is more than just a person. It's a lot of processes need to be users to make shit happen on the system. So that's mostly what you're going to see in there. So if you just do a less on password, that will let us page through the whole file, and you should be able to page down and eventually start to see users in the 1,000 level, which are users that the installation or we added to the system to do stuff. Do you see it in there as you scroll down?
That's it. He's hit it. I still see the secondary guy,
Huh.
but I don't see my primary.
That's weird. Okay, I'm gonna have to come check that out in a little while. Let me make a note of that.
Maybe I set up the account to be private or something else.
My understanding was every user that can do stuff on the system is in the password file, but I could be wrong about that. So-
Yeah, as in, the secondary is 1,001. And earlier one we did, which.
Okay, well, it could be, it's hard. Sometimes these are hard to read, so let's try this. So if you do a grep 1000 /etc/password, PASSWD, does it bring up anything?
Yeah, brings them up.
Okay. Yeah, so it could be, it was just hard to see as you were looking through the file, but it's definitely in there if grep finds it. Okay. I also want to come back to something. Often in the past, we have done this in class and the book has done it, something like cat. So try this with me. slash etc PASSWD, right? That'll just stream through the whole file, just flash by. So then what I want to do is I want to pipe that over to grep. And in grep, I want to say, just look for any line that has 1,000 in it. Okay, so I got two commands here. At the bottom, I have pat slash space slash etc pat PASSWD space pipe, which sends the output to standard output somewhere else. I'm sending it to grep, and I'm telling grep to look for any line with 1,000 in it. Compare that to the line above where I ran grep 1,000 on etc password. Enter, if you haven't already. They both look like, well, they both output the same exact thing. Okay. Now, if you just need to find something in a file, you just use grep directly. There's no reason to use cat first and then send it to grep, because that is more work for the system, because the system has to load cat. Cat has to run the file. Then the system has to use pipe. Pipe is a command. So that's another command I have to run. Then I have to run grep. So the second way I did it, I had to use 3 commands to make something happen. The first time I did, I used 1 command to make that. Right? And again, in Linux, there's lots of different ways to do things. And often we try to find the simplest way. And finding the simplest way is often based on experience, right? You gain those ideas based on experience. So that's an interesting thing that struck me the other day when I was thinking about shell scripting and piping and redirecting. Okay, yeah.
Are you able to use T to like grab stuff from like online files from online and throw it into another file or a directory?
Sure. So find something online. So like at some web server
Yeah,
somewhere.
like you grab something from the web and then you throw it into like a directory or file.
Yeah, so there's a program called wget that I could use. And if I give wget a web address, like https:// let's go to the server I just set up, BlueCC. You can try this too. BlueCCDCT.org, and then / to go to the root directory. And then I can pipe that over to, let's pipe it over to grep first. And with grep, we're going to look for, let's look for quote less than p greater than, close quote. And then I'm going to pipe that to T. I think this will work. And with T, I'm going to store that in a file called web page paragraphs. Paragraphs. And I like putting extensions. You don't have to. A lot of times you'll see people will just write to a file name with no extension. I like extension because it gives me a hint as to what I might be looking at. So I'm just going to call this .txt because it is going to be text. Okay. I don't know if this is going to work. Let's try it. Oh.
Definitely download something.
Okay. wget was not the program I wanted to use. I forget, wget downloads it. I want something that's going to stream a web page. My mind's running blank. I know several commands to do it, but I can't think of them right now. Let's see.
Because with something like cloud server, I've been using T a lot to grab stuff from online and it seems to be working.
Command line stream web page. Thinking. Curl. Maybe curl will work. That was the other one. All right, let's try the same thing with curl.
Yeah, I've been using Perl.
Oh, wget. Oh, it says wget would work if I use the -o. All right, maybe. So again, I don't necessarily trust what that gives me, so I'm going to do a man on wget. And
I use Perl.
yeah, curl was the one I was trying to think of that wouldn't come to mind a minute ago. I use curl sometimes. So it recommended the capital O option. I should have just searched for capital O.
Yeah.
Yeah. No, well, slash in less to search for something is easier. Oh, document will not be written. Let's see.
I'll put that.
Okay, I get you. Oh, and then dash. All right, let's try that. Quit. Dash capital O dash space. Oh, it did it. Yeah, so it did download the file to standard out, it looks like. And then grep said, oh, I found a few lines that have a P. Those are paragraph markers in the web page. It's part of HTML. And so now if I look in LESS on, what do they call it? Web page. There it is. Yeah. Okay. And curl, I think, would have done the same thing if I just did curl with no options. Let's try curl. Boom. Yeah. Cool. Thank you for asking that. That was fun. All right. Let me see. I think we're done with this part, and I think we're ready to move on to part 2. Let me double check what I said to do here.
Wait, so is this?
That's part
is that
1.
Two? The script?
No, this is still part 1. So we're going to do part 2 next. Okay, so we are done with, based on what we did last class and this class, we are done with this assignment right here. This right here was if you went through the commands in the book, he does a bunch of commands on that file. So you don't have to do that. All right, so let's exit script. And then whatever you called it, change the name. So let's see. Something I do often to double check what I just did. If I hit up arrow, it'll show me the last thing I typed. So I had saved mine in CS140 work, chapter 7, part 1S. So whatever you called yours, if it's not called chapter 7-part 1.ts, then rename it. Do you remember how to rename on the command line? Move, correct. Yeah. So that's a lot to type. So if I wanted to rename, I'd rather CD into that directory because I'm probably going to do more work in there. So if yours was in another directory, and then I could move the file, what do they call it? Part. So I want it to be called part1.ts. And then once you get that, we're going to start a part 2.